Alright, we are rolling just in time for the sirens outside. Hopefully that's a false alarm, whatever it is. Alright, so, you play video games. I love video games, but I don't find a lot of time to do it, and more, a lot of video games make me pukey. And I can get over it. Like Skyrim made me really pukey at first, and eventually I got past that, which was good. But it's kind of an issue lately. Yeah, like motion sickness. So I don't know, what are people's favorite video games here? Like Desert Island, 1 game each. Besides the dot game and sticks, obviously. And Battletoads. XCOM, cool. Oh, Minecraft is awesome, yeah. FTL, I don't think I have the CPU for. Because somebody recommended that to me once, but said serious horsepower. Is it really? Okay. Pokemon, yeah, classic. City Skylines, cool. Oh, okay. Well, I'll take another look at it. Yeah, maybe next year I'll retire and I'll just play video games and I can, like, Twitch those or something. Alright, cool. So how's PA4? Oh, okay, yeah, definitely come by office. Let's get your Eclipse setup working, because that's going to be a big time saver. And reminder, everything is canceled for me tomorrow, so no office hours, no class. But I'll have hours Thursday morning. Oh, okay, good. That's definite progress. So let's talk about graphics a little. For making the board and drawing the lines, you're probably going to want to do this by hand. You're probably going to want to actually draw the individual lines. And, you know, if we're trying to make shapes, rectangles, circles, things like that, we have methods in the graphics class for doing that. But given an array of dots and well, drawing the dots, you're going to want to do by hand. And, you know, that can be our nested for loop or something. But then drawing the lines to connect them, that's just going to be a draw line call. And draw a line, you basically give it XY coordinates for the beginning and the ending of a line. The trick is, you know, knowing where you want to draw the line from and to. And that depends on knowing where somebody clicked in your board area and figuring out what box they're in, and then figuring out what line of that box they're asking to draw, and then finding the coordinates of that and then calling draw line. So I want to go through some of the operations around that, related to that. Some of this stuff that we can think of as coordinate arithmetic. And so let's sort of a little abstractly think about drawing in graphics. So we already know one funny thing, which is the origin is in the upper left instead of the lower left. X still increases to the right, but Y increases from top to bottom. So other than being flipped, it's like Cartesian coordinates. And we can think of any point in here as having coordinates x, y. And there's some notion of, you know, what the width of our drawing area is and what the height. And so x would basically vary from 0 to usually width minus 1, and y would vary from 0 to height minus 1, because we start from 0. And so suppose that sitting on top of this we have a pattern of boxes. So here's a really sparse, like 3x4 array of boxes. And when the person clicks with their mouse, you're going to set up a listener ahead of time that will cause that to call a piece of code that you've written, and in that piece of code you can pick up the XY coordinates of the mouse click. Okay, we'll play with this in a few minutes. But your goal is, you know, at that point you need to figure out that you're sitting inside this box, and you need to figure out which line the person was trying to draw. And that's basically a question of which of these 4 edges did the person click closest to. Now this is a little ambiguous, but I'd say it's probably closer to this line than this one, and certainly it's closer than any of these distances. So I would say if they click right here, they're asking to draw a line between here and here. So what do we have to do? So find mouse XY coordinates, decide which box, decide which edge of that box, and then find the coordinates for that edge, the beginning and the ending of it, so that you can call draw line and say draw a line there. So I've posted on Canvas a copy of this. It's a 1-page PDF. Some of this will help you. Some of it will maybe help you down the road, maybe not. But this is just kind of a way to think about some of these concepts, in particular where you have one large area and you're breaking it into a regular collection of sub areas. Okay, what I'm thinking of is cells. And so there's a few things to keep in mind here. So, you know, this is the width that's going across, this is the height. X is going across, Y is going down. So make sure you're clear on row and column. Okay, columns increase as you move across. This is column 0, 1, 2, 3, 4. Rows increase as you move down. This is row 0, 1, 2, 3, 4, 5, 6. Alright, so columns go across, rows go down. There's no reason for that. That's just something you have to remember. And once it's internalized, it will make a lot of things easier. I think of it visually as columns. I think of, like, you know, Greek architecture columns, these big tall things. So that's a column, that's a column, that's a column. Right, so my column number increases going like that. And then rows are just like rows of a table. So those go down. Okay, so we've got X and Y. We've got column and row. The third thing we have to keep straight is when we have a two-dimensional collection and we have coordinates like this. So bracket something comma something. This first thing is the row number. The second thing is the column number. So the coordinates in a two-dimensional array, the first number is how far you go down, the second is how far you go across. And so this cell, for example, 1, 3 means move down 1 and move over 1, 2, 3. This cell 3, 2 says starting from, you know, this upper left corner, move down 3, 1, 2, 3, and then move over 2, 1, 2. So this would be 0, 0 up here, and anything else, move down the first number and move across the second number. Those are pretty standard. they'll be absolutely consistent with everything I do in this course, except when I mess up. And you'll find this a lot of other places. You'll find this in assembly language when you look at accessing two-dimensional arrays. You'll find it in graphics. You'll find it in all kinds of situations. So X, Y, columns, rows, row, comma, column. Okay, so those are three things to try to keep straight. If we know that this cell has a height of 50 and we have 10 cells, we can figure out the height of the whole area. It's just 10 times 50. If there's 12 cells, the height would be 12 times 50. If there's 2 cells, the height would be 2 times 50. So using those ideas, we can also work the problem in reverse. If we know what the height of this area is and we want a particular number of cells, we can figure out the height of each cell. It's the total height divided by the number of rows, because row is how many of these we have. And similarly, the width of a cell is the total width of our area divided by the number of columns. So if we have 5 columns, this width is, a fifth of the total width. These formulas are not hard, but when you've got a whole bunch of them and you're writing code around them, it's really easy, to flip something over and end up doing, rows divided by height instead of height divided by rows. Or just swap rows and columns, or X and Y. So I've got all this in one place. If it's useful, good. All right, let's look at coordinates. So suppose we have a cell with a certain index, row, comma, column. So we're down, row and across column. If we want to know the coordinates of the corners of this, it's a pretty simple calculation. The upper left corner is just the x-coordinate will be the number of the column times the width of each cell. So column 0, the x-coordinate is 0. Column 1, this corner is just, the width of a cell. Column 2, the coordinates of this corner is just 2 times the width of a cell. Column 3, the coordinates of this corner is 1, 2, 3 times the width of the cell. So the upper left corner, the x-coordinate is your column number times the cell width. And similarly, your y-coordinate is the row number times the cell height. And once you know the coordinates of this corner, you can find the coordinates of the other corners. This one, the x-coordinate increases by cell width. This corner, the y-coordinate increases by cell height. And this corner, both coordinates increase. So it's x plus cell width, y plus cell height. So if somebody clicks and if you want to do something, if you want to draw, cell 3, 2, right? You can find the coordinates of this line. It's 3 times cell width and or 2 times cell width and 3 times cell height. So in your paint method, when you're drawing your rectangles, right, you can use these formulas to find the XY coordinates for the beginning and end of each of these 4 lines, right, and draw any or all of those lines that you need to. The inverse problem is if somebody clicks somewhere, how do you figure out what cell they clicked in? And if you run these equations backwards, it's a pretty simple formula. X divided by cell width, that's your column. Y divided by cell height, that's your row. So if you take the XY coordinates where you clicked and just divide by the cell height, that gives you the row. Divide by cell width, that's the column. And then once you know what the row and column number was of the cell they clicked in, you can find the coordinates for the corners of the box they clicked in. And then you can do things like, decide which box they clicked in, which one they were closest to, and so on and so forth. So this is summarized on here for whatever help it offers. But my suggestion is work through this yourself, right? Don't just take this as, I guess I have to use this formula here. Don't worry about this at first, but do the math yourself. Try to figure out, what are the coordinates of this corner of this box, just by knowing that I'm in row 1 and column 3. And, you know, our boxes are nominally 50 by 50, but, you know, I said keep those as variables, so they might be, you know, cell width and cell height for X and Y dimensions. All right, and this will pop up lots of places over the next few years, so it's good stuff to work through. All right, let's play with mouse events. So we've played with button events, and we played with a resize event yesterday. Let's go ahead and look at buttons. Well, this is weird because I just deleted all of my files and they still seem to be there. That's interesting. I might have done something really bad just now. Oh well. All right, that works. All right, so let's make a project and let's start picking up mouse events. So I'm going to do a file, new Java project, and I'm going to call it, I don't know, what am I going to call it? Someone give me a name. It's your chance for fame. File, excellent. Alright, so I'm going to create a JFrame. Alright, well, we'll call our mainframe new game. Alright, so let's go into the design window. Let's do our usual setup. So let's go ahead and put an absolute layout manager. And even though I have a J panel in here, I'm going to make a new J panel inside that we're going to use to do our drawing. And I'll give it a border. And I'm going to come into my code. I'm going to change where this original J-frame is created so that I can see it easily. So there's our basic object of interest. You know what? I'm going to make this thing bigger. Alright, there's a nice drawing area. Alright. Yeah, Eclipse is definitely awesome. So these coordinates are in terms of pixels. Oh, this was another thing I meant to say when we were talking about graphics, right? So usually everything in graphics is measured in pixels. Pixel is like an individual dot. When you get a monitor, if it's, you know, 1920 by 1080. That's the number of pixels that you have. This is usually going across, and this is going up and down. So the coordinates that you put in for creating something are, you know, where you are relative to this frame. I'm making banana bread today because my fruit flies are out of control. So these numbers are like, you know, 112 pixels from the left, 61 from the right, and a total of 535 across and 371 up and down. That's that inner panel that I'm drawing, and those coordinates are relative to the J-frame, I believe. The J-frame itself, I gave an X-coordinate of 4,000 because I have a dual display. So my main display is 3,800 something pixels across, and so 4,000 is in the beginning of this second window because I have my window extended. And then this is, I think, 1,900 across. All right, so let's play with the mouse. So I'm going to come into this panel in here, and I'm going to add a mouse event. So I'm going to say add event handler for mouse motion. I'm going to do mouse drag. So this will only happen when I'm holding down a mouse button and moving. And I'm going to come in here, and let's just put in a print message. Alright, so the mouse dragged method is called with an argument of type mouse event, and if I look up the documentation for a mouse event, it has methods called getX and getY, which will give me the X and Y coordinates of the mouse event for which this was called. So if I run this and I come in here and I hold down a mouse button and I start moving, I start seeing the XY coordinates. And you can see upper left is pretty close to 0, 0. And X increases as we move across, and Y increases as we move down. And if I lift up the button and I move, then I'm not getting events. Now if I wanted events when I moved, I could use a mouse motion instead of a mouse dragged. So here's what we want to do. We want to draw a big dot and have that dot follow our mouse around. And the trick is we can't call, you know, g.filloval right here because we're not inside our paint method. And remember, all of our painting happens from inside paint. So we've got to do a few things. First of all, we have to make our own paint method, which means we have to create our own version of a J panel so that we can override what paint does. So these are probably worth listing. So one, we're going to make a class that extends a J panel. Two, we're going to make our own paint method. And then three, which happens when there's a mouse event. We can't call paint, but what we can, and we can't call, you know, fill oval. What we can do is modify memory, which is used by paint. And then we're going to say repaint. So we extend the J panel, we make our own paint method in there to, in our case, draw an oval or a circle. And we're going to set up our mouse event so that when we click the mouse, when we're moving the mouse, we update some value in memory so that paint will draw the circle at the right place. And then we're going to call repaint. And repaint will say, hey, go ahead and call paint for me. Paint will get called, pick up that location from memory, draw the oval. And this is kind of the 4 steps that we'll do repeatedly. So first thing is, you know, we're creating this panel. It's called panel. It's a J panel. We're going to change that to our own version of a panel. So let's call this Tuesday panel. So Tuesday panel equals new Tuesday panel. And let's create a Tuesday panel. So we'll say file new class, and we'll call it Tuesday panel. Not root panel. To panel. I cannot. Wonder if we can browse. Yeah, I can't remember the name of the swing class, so I'm just, yeah, I'll just finish it and type this in by hand. So there's a Tuesday panel. I'm going to say it extends JPanel. And I'm going to make a paint method. So public void paint graphics G. And we need to import JPanel from Swing, and we need to import graphics from AWT. And so this should work fine now. And if I run this, you know, nothing blew up, but our panel looks like it disappeared. Well, it's still there. We're still picking up events on it. And if we click outside, we don't. But our border's no longer there. So remember the trick that we said in the beginning of paint. Let's call paint from the original JPanel class. So we'll say super.paint G. And yeah, I did that kind of fast, but like when something is underlined in red, you can hover your mouse over it. So I'm not pressing any buttons. I'm just moving the mouse and waiting. And it says JPanel cannot be resolved to a type. 3 quick fixes available. The first says import JPanel from Java X Swing. The second says create a class named JPanel. And the third is fix the project setup. So if I click this first one, it's just a left click where it says import, it goes ahead and writes that import statement for me. And that alone is worth the price of admission for Eclipse, because particularly with these GUIs, we're going to import a bunch of stuff. So yeah, that's pretty slick. All right, so this should all be set. We're going to call the superclass paint method, which will, you know, do all the things that a JPanel normally does, including, you know, looking to see if there's a border and drawing the border. And so now we're back to where we were. We've got our panel, it's got a border. I can click and drag and see XY coordinates. All right, now how do we get a big dot to draw while we're dragging our mouse? Right here is where we are when we're dragging the mouse. We can't say fill oval because we're not inside a paint method. All we can do is try to set things up so that the paint method will draw that dot for us. So we're going to write a method inside our Tuesday panel class. It's going to be called save X and Y. So the code I'm going to write here is basically panel.save X and Y. And I'm going to pass the XY coordinates I want it to save. So e.getX and e.getY. And that's fine, except we haven't written save X and Y yet. So we'll come into our Tuesday panel and we'll write that method. So this will let someone save an XY pair for later painting. So I'll do a public void save X and Y. And we'll take in arguments X and Y. And where should we save these? Well, you know, because these are just temporary variables. And so if I don't copy these into a class variable somewhere, then they're going to disappear. So I'm going to make a pair of variables up here. So these are the last save values, and then in here I'm just going to say last x equals x, last y equals y. Alright, we got a lot of interaction going on now. Click on the mouse, come down here to the mouse drag method, find the x and y coordinates of the mouse, call the save x and y method in the panel. Panel's save x and y method takes those, copies those xy coordinates to these variables up here. Now if we use these to draw a dot, we should always draw at the last saved x and y coordinates. So let's do a paint command here, g.fill oval, and we'll put it at the last x and the last y, and we'll just make a 40 by 40 dot. Run that, and nothing's happening. We got one dot, but even though it's picking up mouse events, we're not seeing that dot move. So what's missing here? Repaint ski, right? If I resize, suddenly my dot jumps to whatever my last position was. Really simple problem, but it can be really frustrating, especially a late, after a number of hours. If I want paint to run, I've got to tell it, go ahead and call the paint method. So I'm going to say, in this case, it's panel's paint method I want, panel.repaint. And now we got a big dot following us around. And since I'm dragging, I can get off the window and it's still calling my method because, this is a drag event. So I can come down to negative coordinates. But drawing at those absurd coordinates doesn't show us anything. Alright, so extend the J panel, make your paint method. When you want something to appear or change in your display, change memory. Right? In this case, we change the values of that last x, last y pair of integers, and then call repaint. And your paint method has to use those things that you set in memory to do the painting. So for dots, this means, when somebody clicks, that's where you're going to go ahead and figure out what box they clicked in, what line they were clicking next to. Was that line already drawn? If it's not, let's set the flags in that box object to be true. So person clicks on this line, they're in this box. See if the bottom of this box, if that Boolean is false. If it is, mark it true, and then come down here and mark the top box true. And at that point, check to see if the box is completed now, and if it is, give them an initial and so on. But when you're done with all of that, call paint. And what paint has to do is look at your array of boxes, and each time that it finds a line, go ahead and draw that line. And how do you figure out the coordinates? You do your coordinate arithmetic. Alright, let me show you a trick. This is not something you want to do, but if you're stuck with a crowd and you got to impress them really quickly. If we don't call the superclass's paint method, right, the only thing that paint's going to do is draw an oval. And that's the only thing it's going to do. Which means if we run this, we get this kind of behavior. Now normally, whenever paint is called, the screen is erased. But that's handled by the superclass's paint. So if we're not calling super.paint, this doesn't get erased, and we get this, kind of cool persistent effect. But if we resize the window, that will call the superclass's paint, and everything disappears, except our current dot position. But that's not a good way to draw you know, if we wanted to make a program that would let us draw lines like this, that's really not a good way to do it. Because we're really utilizing a bug, right? The fact that we're not erasing the display gives us this persistent effect. Yeah, that's exactly like when you try to drag a window and you see those ghosts of it because something is hung up somewhere, and that's exactly what's happening, right? The system that should be refreshing the display is not running because something is hung up somewhere. So what if we wanted that kind of persistent effect? What if we wanted to, you know, instead of just having one dot follow us around, what if we wanted to leave a trail of dots so that we could see a whole line? What might we want to do? Any ideas if we wanted to actually, you know, the proper way show a line wherever we move instead of just showing one dot? How can we do that? Save the positions in memory, you got it. Right? So make something like an array or maybe a linked list and just start storing these. So we could lowball this to begin with. Alright, let's make an array of these things, and we don't need a last x, last y anymore, but let's keep track of where we are in our array, and when we get an xy pair to save, let's save it at, let's do it at x data bracket xy loc equals x. Save the x and y value, and we'll increment the location, and we'll roll it over. So what have we just implemented here? What is this thing called? I think CSE222. Well, let's go ahead and finish this up and run it, and I think when you see it running, you'll see what it's called. I'm going to make my dots a little smaller. Alright, what do we got here? When we save our XY location, instead of just saving them in a pair of integers, we're going to save them into locations in an array, which can hold 100 things. We're going to start off at location 0 in the array. We're going to increment that location. And when it gets to 100, we're going to set it back to 0. And our paint method is always going to paint the 100 things in our array, so x data and y data as I goes from 0 to 99. And if we run this, we've got a snake. Almost a stack. It's actually a queue, but it could just as well be a stack. But yeah, it's basically a circular queue. Yeah, they're just pretty. That's like oddly fun. Woo. And you can have speed contests and see how many circles you can draw. Right? So that's a you know, one version of this. Now, if we wanted to be able to store more things, we could use a linked list, and a linked list would, you know, let us grow dynamically, and we could cut it off, you know, at some other point, and so on. But this is, you know, this is all relatively trivial right now. If I tried to do this in C, you know, using some low-level windowing system, this would be a nightmare, right? And, you know, from drawing a single dot to doing this was, you know, really just make an array, save in an array, draw from an array in a loop. It's really a few lines of code. So everything that you need to be able to do the dots game, right, you either already know or you can probably figure out. As far as algorithms go, and the painting is really not much more complex than, it's less complex than what we just did, right? It's really go through an array of boxes and draw lines and so on and so forth. But there's lots of little details. So let me give you one more example of a detail. Suppose the person clicks right here. Right. So we need to know that they're oh, buttons in Python. Yeah, that could be tricky. Let's say the person clicks right here. We'd like to know that they're trying to draw this line as opposed to that one or that one or that one. So how do we do that? Well, you've got the XY coordinates of this dot. You do some math and you find the XY coordinates for these corners. And now you have to calculate 4 distances. Calculate the distance in Y from this bottom line and from this top line. Calculate the distance in X from the left edge and from the right edge. And we know the coordinates of, you know, we know the Y coordinate of the top line is just, you know, row times cell height. The Y coordinate of this line is row times cell height plus, you know, cell height, and so on and so forth. Find these 4 distances, see which one is smaller. Whichever one is smallest, that's the line that they were trying to click on. Hey, physics midterm, awesome. You went the distance, that's what counts. All right, and if someone clicks ambiguously, like right here, where this distance is exactly the same as this distance, what do? Well, it depends on your code, right? You can just kind of let your code do whatever it does, which is, you know, it might choose this one because it finds that first, or it might use less than or equal to and pick this one, you know. Or you could put in some margin, and you could say, you know, find the smallest distance, and if that's within, you know, 5 units of some other distance, don't take it as a click. Call it ambiguous, and force them to be, you know, at least more than 5 units closer to one edge than any other edge. All right, I'm curious about physics midterm as to why that was overlapping with class. Was that like a in-class midterm that went long, or what? I'm just sort of curious. Huh, okay. All right. Well, hopefully the final doesn't conflict. Cool. All right. If you know something like that's happening, look, give me a heads up if you think of it. And but I mean, I recorded this anyway, so no big deal. But I could have done that secret unscheduled pop quiz that counts for the entire course or something. No. Yeah, that's cool. All right. So you probably got most everything you need to do the dots game. But again, break it into pieces, right? So start with just an array of dots, and then try to pick up mouse events. and you know, don't get bogged down on this, but get a piece of paper and do these calculations yourself. Try to figure out, how do I go from an XY coordinate to the row and column that the person clicked in. And then once you know the row and column, how do I figure out the Y coordinate for the top and bottom lines, the X coordinate for the left and right lines, and then how do I figure out which line they clicked next to. And then at that point, right, start putting together your box class and your board class with the array of boxes, and you know, go ahead and set some of these things to true when somebody clicks on an edge, and then write your paint method. And your paint method, go through the array of boxes, and for each box, you know, if the top Boolean is true, draw the top line. If the left Boolean is true, draw the left line. And how do you draw those? Do some coordinate arithmetic to find the starting and ending coordinates for each of the lines you want to draw, and then just call, you know, the drawLine method in the graphics class. So g.drawLine. So that's all, you know, a big nested for loop inside your paint method that basically looks at your data in the boxes and draws lines. Alright, that's all we got for today. So, keep working on that stuff. Enjoy the afternoon. I'm off tomorrow, and I will see you on Thursday. Thanks, everyone.